Shall I? What do you think?
I'm hoping.
Okay, then I will.
You'll learn fast here that I'm probably the most annoying student.
Okay, that's,
Because I know the least and I ask a lot of questions.
that's okay. I'll take your word for it, and I'm happy to answer questions all the time. Okay, so let's see, Rami,
Right here.
okay, Mimi, Rami.
It's Rami, yeah.
Right. Jose, okay, Yuming, great, Onassis, okay, Utenda, not here yet, okay, Zyke or Zeke? Zyke, Zeke, Zeke, okay, good, Cliff, okay, Juan, okay, your name is?
Shreya.
Send me an email. And I'm gonna have. say hello.
Check, 1, 2, okay.
Send a copy of the lecture notes second time, just for good measure. And, send another one out. I put my emails on a 2-minute delay now. All of a sudden, this is a feature in Outlook. So one website you should be familiar with, kind of as a good practice going forward, I suppose, is the website for the book. You may have downloaded the book previously in R. You're going to want Python 2. It's statlearning.com. I usually search for ISL and it comes up. It's free. This book has been around. There was the original book was written by the authors, the last two authors here, Hastie and Tim Sharani. These are kind of like senior professors at Stanford. Have been there since the 90s. And they wrote a book called Elements of Statistical Learning, I suppose, or something. And it's a popular book, very got a lot of widespread use. And being from the statistics department, they naturally coded everything up in R. Then in some point, 2009, second edition of that book came out. They decided to make a slightly easier book, same content, but less math. And at that point, I think Gareth James and Daniela Witten pitched in to help create the book. They wrote the text and the diagrams, and et cetera, and then maybe the R code. They might not even have had R code in the bigger one, I forget now. And then, so this one's been around for a while too, probably 2015 or something like that. They've always made it available for free. You know, you can buy one if you want, but free is good, right? And then finally they said, you know, let's get one out there in Python, because Python's a pretty popular language, and needless to say. The book will also be popular. And then they extended both the second edition of this and probably that one by default, added a few topics. I think this person, Jonathan Taylor, he might have added the Python stuff, or they also put some stuff in on deep learning. And there you have it. I'm going to send one more article out. This will take 2 minutes to get to you. Do my I just came across this article on LinkedIn today. Feel free to, I'm on LinkedIn, of course. Feel free to send me a connection. I'll try to get to it when I see them all. This article is pretty interesting. Down there. So I have, kind of weird, I have Outlook on. I have Windows PC at home, I have a Mac Studio at home, I've got a Windows laptop, which I used to use to teach this class, but I just started using the Mac laptop a lot, so I decided to teach it this semester. Anybody on Mac? 1, 2, 3, okay, that's actually 4. All right, so actually majority of that. Not counting the person who's missing as a go today. But it shouldn't matter because I'll teach you things that replicate the Mac situation. The real winning thing I found, where Mac really wins, the best thing about Mac is really the terminal. That's something that Windows never really kind of mastered. Mac itself, OS X, is a version of a Unix operating system, which was the dominant operating system in the 70s, I suppose, until Windows came along. MS-DOS, Microsoft Disk Operating System, was the predecessor of Windows. It underlies Windows, but it used to be a command-driven based thing like this. And then Windows came out in the early 90s, or 95, I guess, was the first really good Windows version, maybe, or 94 even. And but their terminal is really good. So Mac OS X is a variation on Unix, the same way Linux is a open source version of Unix, and the terminal is really useful. The way I don't know why this happens, but once you have Python on it, it always tells you which drive you're at. The analog to this on Windows will be the Anaconda prompt. It gives you a window when you open up an Anaconda shell. It gives you a window just like this. Gives you a Python environment baked in, and it's a good place to work on Python. So in teaching this class, I'm going to pop up this article while we're at it. What is the landscape? I've been teaching this class with Professor McCollins probably about 5 years at this point. I suppose maybe 6. I have to look it up. But things are really changing, obviously, right? Because the advent of AI for coding has really completely overhauled the landscape. And the question is, how do you function in this? This article, I saw it. It's probably a fairly recent article. I sent it to you. Actually, it says 2 March, so it's only about a week old. This one happens to be available on Archive, which is a Cornell run repository or curated repository for mostly, you get a lot of articles, but I only see the finance ones. There's probably other scientific articles there. The other one that does the similar function is SSRN, Social Science Research Network. So these gentlemen, I guess, looks like 4 men probably, working at the Oxford Mann Institute of Quantitative Finance, did a study on various time series models that are specialized. Let me actually change the light just a little bit. I haven't read the article yet, I just got it today, but it looked really interesting. And they talk about all of the conceivable, they look at many different forecasting methods and they come to some conclusions, and they apparently have some success, which is kind of interesting. They publish it, right? They're not looking to just make money off of it, they're researchers. And I teach a course in the fall. I've taught several times. It's called algorithmic trading, or algorithmic and high frequency trading. We don't really get that deep into the high frequency stuff because that's a really highly specialized realm. Computer scientists with 25 years of experience working at the level of the operating system, at the chip, at the bus, on the CPU, and it'd be hard to break into starting from scratch, starting from where I am as far as that goes, because it's specialized computer scientist skills, and I don't know that the market will always continue to grow. But algorithmic trading, or systematic trading as it's called in many contexts, really just involve the basic process of taking data that's available from the past, using it to forecast what happens in the future of that past. Always the issues, make sure if I'm going to run a trading model, and say I'm going to execute a trade on this day, but in 2017, make sure that my executed trade only incorporates data available to 2017. There's a whole kind of soft science about how to avoid leaking the future into your model, because you can't trade on the future, so your model will look good on paper. And there's a lot of other things to worry about. But these guys have written this paper. It says, look how great this is, and we'll see, how does this not dissipate the advantages that you might have in a model, right? One of the the fundamental premise of trading businesses, I should say of financial literature on trading businesses going back to, say, at least 1990, and certainly even before then, is that the what's so-called efficient market hypothesis. I think Eugene Fama is the guy who did that, or maybe it was one of the other Chicago people in the 50s and 60s and 70s, which just basically says that the current prices of an asset reflect all knowledge about that asset, and you cannot outfox other people by trading on past data. It kind of is sort of like a complicated way of saying, an academic way of saying, that technical analysis does not work. That's the kind of premise, right?
Because how you make money in these things by capitalizing on inefficiencies.
Well, so the hypothesis, right, the efficient market hypothesis says that all information, including possibly non-public information, is already baked into the price, because if someone has non-public information and they act on it, it gets into the price. This is an argument that's going on right now about these forecasting markets, Polymarket and Kalshi. Polymarket in particular has come under a lot of scrutiny because of three recent events: the capture of Nicolas Maduro, the bombing of I forget what the second one was, and the third one is the death of the Ayatollah Khamenei, right? Which was that right before, actually, I think maybe it's just the invasion, the beginning of the battle. Right before these things happened, people came into Polymarket and opened accounts. For example, with Nicolas Maduro, I think the contract on Polymarket was, will Maduro leave office by December 31st? I think that's the day. I guess we maybe did the thing on Christmas, I forget. And someone comes in with like $100,000, and the next day they attack Venezuela and capture him, and the contract is then worth $500,000. Someone made like $400,000. And Magna My Man, I think was the user's name. And the same thing happened when Khamenei died, which was that like about 4 or 5 hours before the invasion last week or 2 weeks ago, a large series of bets were made saying, and these are contracts, that were trading at like 5 cents or 10 cents or 20 cents, which represents per dollar the probability that the market's currently assigning. The way prediction markets work is you place a bet at whatever price is in the prediction market. It's going to be a number between 0 and 100 cents, and that in some way, like, will J.D. Vance be the Republican nominee in 2028? It's probably trading at like 27 cents or something right now. That's the markets. And there'll be somebody on Marca and all the other possible candidates, probably summing up to almost one, since most of the famous possibilities are already there. And then they trade over time as people become more or less confident that the outcome will, and you can bet yes or you can bet no. Well, you know, so these invade Iran things, you know, will we invade Iran or will we bomb Iran like by tomorrow? We're trading at like, you know, 12 cents, and then all of a sudden someone puts a lot of money on it, and then the bombs start flying and it's trading at $1. So this clearly speaks to inside information leaking out of somewhere. Now, I read an article about this in The Atlantic, I think, which said, well, the thing with a thing like an invasion, it's a pretty complicated process that a lot of people do gain awareness of in the day or two before. All of the soldiers, you know, there's a whole, I mean, just not the people at the president and the cabinet level are aware.
Mobilization.
You know, generals are aware a couple of days early. I mean, you know, the people were over there already. But the fact that we're going to start doing this thing at 10 o'clock in the evening, whatever time we start, that information has to be conveyed to all the people. So there's possibly a lot of places where it could leak out. One of the questions that this article raised was, you know, it starts out with this premise. I think we can safely assume that Ayatollah Khomeini was not a follower of polymarchers, because had he been, he would have seen that contracts on his removal from, quote unquote, removal from office had risen from 10 cents to 25 cents in the space of just a couple of hours the night before he died. And maybe he would have like gone deeper into the bunker. And more to the point, which is that other operational aspects of the of military events could become leaked out to people who shouldn't know about it, potentially putting in harm's way the lives of whoever, whatever side you're supporting in this particular instance. So information theory, right? So what we're going to do in this class, how can I teach this class? Tonight we're going to talk about principal components analysis. I put this out there for you to read, and you can read it in your time. I'll give you a quick overview of what tonight's lesson looks like. And actually, there's one more thing I want to do before I do that. I want to go back to that ISLO website. The book is quite nice. It's an interesting book. Because we have a book here. I don't want that. I want the slides. Here are the people. This is Tip Shirani. You may have learned about the lasso with Professor McDonald. I think Tip Shirani is the guy who did the lasso. It's very controversial. The L1. Yes. Okay. I'll get the book.
They also have a series of YouTube videos for everything in the book too.
I bet they do. Hopefully they
With
don't
both
put that-
R and then in the past couple of years they put the new Python ones in too.
I bet they're excellent, right?
Yep, that's how I found about this book years ago.
Yeah,
There it is right there.
The online courses, right. I'll have to check them out. Right here, figures. Let me pull up one of the figures. So we're going to start with slides. We're going to start in chapter 12 with the concept of principal components analysis. And let's just So, as is discussed, well, actually, it's first I'd like to talk about what is principal components analysis before we even get into all of the mucky stuff. So, this is the first idea that you want to think about here, which is you have this data, these purple dots. And you know from having studied linear regression, just looking at the dots, you might come to the idea, hey, you know, I could probably approximate the results of this experiment by a line, right? In this particular case, the variables, the so-called features of the model are population and ad spending for 100 different cities. So it's probably population in thousands and ad spending in millions maybe, okay? And you come to the hypothesis, there's a strong positive linear relationship as you might expect. If you want to buy ads in a big city, you gotta pay more money for it, but you're getting more eyeballs, so you pay more, it's okay, right? And linear regression algorithm, which you're familiar with, is one way to do it. This example, which actually comes out of chapter 6 in the book originally, it might be called PCA regression. The PCA stands for Principal Components Analysis. We'll talk about what it means in great depth tonight and probably next time we meet, okay? And, but it's slightly different. And one of the things we'll see in the lesson is that although the algorithm for computing the PCA does not proceed in this way, you could get this same green line by minimizing the distance in the XY plane, the square distance of all the purple dots. So that is, you take any purple dot and you go straight to the green line at a right angle. Minimizing the distance means you have to intersect, you know, the line you have to draw a line segment that's perpendicular to the green line through the purple dot. Okay, now this is a little bit of a fine point. Let's see how good your geometry is. How is that different from what linear regression does? It is different, I'll tell you that. Think for a second, how is that different? In other words, the linear regression line would be slightly different than this line. And if you think about the way, hazard a guess, Cliff? Right, if something occurs to you immediately, just throw your hand up. Otherwise, I'm really just posing questions to raise the question in your mind, right? So in a linear regression, what we do would be, we would draw, if we wanted to look at how well the optimization works.
Minimize the variance between, it's the line of best fit, it's the one that like minimizes the amount of error.
Okay, but in a way, this also, PCA also minimizes the error. It's just a slightly different error. And the difference is, in PCA, in linear regression, we have the independent variable on the x-axis, the dependent variable on the y-axis. And we define the error to be the distance of the purple dot to the green line in terms of the y-coordinate. We measure the vertical distance. That's the error, right? The error is y hat, the prediction, minus, you know, mx. It's y, the true y, I should say, minus y hat, the mx plus b version once you fit the linear
The bar,
regression.
Y bar.
What?
That's what I always call it.
Oh no, the y bar, you don't want to say that because the y bar is the mean of the y's, right?
Oh, you mean the, okay,
Yeah.
okay, I want you.
And in fact, let me see if I have my pen game going here for a second. I'm sure there's another slide here. Do exactly what I want. Let me pull up my iPad. Okay, so pull this out here. Okay, so we've got, you know, let's just put a couple of dots. And, green line through. So when we do linear regression, we measure these distances. Right, so these are the, you know, this is y1, y2, y3, x, you know, there's an x of course associated, and y4, and then the error is, you know, this is y hat 4, and this will be, you know, y hat 3. These are the predictions, right? So in linear regression, we take a look at all of the correct y's, I'll call it y sub k, and we subtract the estimated y's, y hat, and then we square them, and we take the minimum, you know, where y hat sub k is equal to, you know, it's like what, it's, let's call it x hat 0, no, that's right. So, we call it, let's just go with, you know, m hat x k plus, you know, b hat. we estimate the slope and the intercept using, minimizing this, right? We have to minimize over all choices of M and B. If there's 15 variables, it's just more minimization to be done. And there's a couple of nice solutions involved in linear algebra to get you there. But now what we do in principal components analysis instead is the following. Principal components, we don't draw the difference in the y's. We draw these lines. We get the shortest distance to the line, which is in 2 dimensions. Here. Okay. So in this case, you know, this distance right here is, this is x hat 1, y hat 1, and this here is, this point here is just x1. So we minimize we're focused on both the x and the y coordinate minimization problem, whereas the linear regression we're only focused on the y coordinate minimization problem. And the goal is slightly different, which is why there's a slightly different method. And the goal is to capture x and y as linked to each other in a way that linear regression really just says, can I predict y's given x? Slightly different problem. Okay. And in fact, going back to the book here, the slides from the book,
And that's how it fits the green line, by minimizing the error?
what's that?
And that's how it fits the green line, by minimizing the error?
Yeah, so this green line, the PCA green line, minimizes the perpendicular distances straight to the line. Like, can I get there as quickly as possible? Whereas the linear regression says minimize the amount of stairs that I have to climb up or down to get down to the line.
And all those other lines are normal to that green line.
That's right. The lines I was drawing are now normal. Right? So normal gets you distance. Like how far is this point from this line? It's not this far, which is the vertical, right? It's this far, which is the perpendicular. So one minimizes vertical distances, and the difference, the primary difference really goes back to the first slide here, which is that when we're doing what we're doing is going to be called unsupervised learning. The difference between only in this, there's 2 topics in unsupervised learning. You'll see them both in my after course. Everything you've done so far with Professor McDonald has been supervised learning. The difference is in supervised learning, we have x's that we know, and we know the y coordinates that are associated. You know, we measured the height of every person in this room, and we measured their weights, and we have a set of ordered pairs of things we know. And then we get a new person comes in, they have a certain height, we're going to try to predict their weight by using this linear regression model, right? And we have the correct answers, which is once we estimate our coefficients, the m and the b, we have answers. We know how bad our estimates are. We have that error that we're minimizing. Whereas in principal components analysis, we have all we observe are the features. So in this case, what we called x and y are really just x1 and x2. They're just a set of ordered pairs. x1 doesn't cause x2. They just happen to be part of the data set. And what's a data set going to look like in the end? A data set, the best way to think of any data set, any matrix, is just think about Microsoft Excel, right? And every row is a new customer in your database. And every column is something that you know about their customer. Their name, their address, things they bought in the past, whatever else is relevant. You know how you can imagine there could be many columns of information. Like when you log on to Netflix and it starts making recommendations, you are a row in their customer database. And besides basic information that they've gleaned about you from the internet, they probably know your gender, they know where you live, they probably know how old you are, they probably know how many kids you have in your family. And then they also have this long list of movies that or shows that you watch. you're tracking a lot of information, right? About what you've selected in the past. Right, many of these websites will, like Amazon probably tracks like every movement of your mouse. Right? You know, he stopped and looked at, Tide extra cleaning powder. Maybe we'll show him that, or we'll show him something else. They do, I don't know, maybe they only track clicks, I don't, they can track every, because when you move the mouse, right, so like, for example, if you hover your mouse over a place, sometimes it will pop up and say, oh, this thing is $85, right? It's obviously watching, it's receiving the feedback. There's, nothing that you're doing, it's very hard to maintain privacy at this point. I mean, I see it all the time. You probably have seen this too, more and more frequently. Like my son looks for something. My sons are in their 20s, mid-20s already. Looks for something on the internet, wants to buy barbecue cleaner. And it'll start, like, it'll pop up in my Facebook feed. It'll pop up when I open up the Apple News app. Actually, I don't think I get ads in the news app, but if I go to NewYorkTimes.com, it'll pop up there, right? This is a very sophisticated operation. All right, so supervised learning, the main difference is we only know data which has features. Now, this is P different features in this particular case. Their usage is there will be N rows of data that you know things about, and for each of those N objects, you'll know P things about them. 1 to P. And usually N is much larger than P. You might have 3,000 customers and you know 30 things about all of them, right? And the question is, looking at that blob of data, what can I understand about that group of data? And where this will come up in our first, maybe our primary example, let's just pull up the first example we'll be looking at later this evening. And that is, I usually have a mouse too, but become a little more reliant on my data. Okay. So we're going to look at two problems. So just in case I do some chicanery with this. So this is these are sample data points of the U.S. Treasury yield curve, taken from a website called FRED, which stands for Federal Reserve. That's probably all it stands for. FRED St. Louis has lots of economic data, and you'll see here that back in 2001. The 1 month was at 3.67%, and the 30-year was at 5.5%. And we'll ourselves forward to last week, and the front is at 375, and the back is at 474. And you can kind of choose the granularity. I selected, I guess I want to do. The one thing that Excel, that Mac is not that great at is Excel is still kind of semi-junky in the Mac. Mostly because the hotkeys don't really work the same. Probably
The command function.
yeah. Well, they don't. You'd want them to be the command, but I wanted like freeze pane. If I was in Windows, it would take me less than a second to freeze the panes right there. But up here, I don't even know which menu it's on. I've been using a lot of these for like 30 years, right? Anyway, but in this case, we've got the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points, right? So we have
those would be considered features.
Yeah, every column is a feature, every row is a sample, essentially. Okay, that's the, and you always want to orient things like this. By the way, if you ever find yourself in Excel and you're not oriented like rows and columns, you're doing it backwards. If you can't drag your formulas down, then you've made a mistake. And if you've got like a blob of data here, you got another blob of data over here, you got another blob of data over here, that's okay when you're kind of like hacking things out, but you can't leave them. it's a spreadsheet for a reason. One of my earlier bosses pointed out. Okay, so what principal components is going to do in the case of interest rates, it's going to recognize that even though every day has 10 different observations, these 10 different features, there's really only about, so in theory, each data point is a point in 10-dimensional space. It's not that hard to imagine 10-dimensional space, right? You got your straight line, pick a number on the line, 5, okay, that's one dimension. You got your plane, pick a number on the plane, 5, 3, okay, that's like over here. All right, now in the room, 5, 3, 7, that's like this, the corner of this desk has coordinates, okay? That's as far as our geometry notion will carry us because we live in 3 dimensions. But you can imagine 10-dimensional space has 10 coordinates, right? So in theory, to describe the yield curve, you need to give me 10 numbers every day to tell me what's happening. And I say, how much did it change by? You got to tell me 10 different changes. In practice, we'll find out that usually 3 is about enough to capture almost all of the information in the curve. And if you can measure your sensitivity to those 3 exposures, which we'll see have names in a moment, then you can understand where you are exposed in your book and how you should possibly, whether your exposure reflects your opinions about. You don't have to know all 10. Like if you're running an interest rate book on a desk, what they would do is this: they take all your positions that have interest rate sensitivity, and one note at a time, they'll move the price by the interest rate by 1 basis point up usually, or maybe down. Price is up. Well, let's just say down. So 367, they say it goes down to 366. They revalue the whole book. If it's an efficient system, it only values those instruments that depend on that node. And then they recalculate your book and they say your book made or lost this much money on that. And that's called the BP01, the DVBP, the DV01, the dollar value of 1 basis point. This is what's going to happen to you if that node drops by 1 basis point. Then they'll do the same thing for the next node, and the next node, and the next node, and then you'll have 10 exposures that tell you, where your hedges are. But like you'll learn things pretty quickly that if you've got a positive exposure in the 5-year bucket and a negative exposure in the 7-year bucket, it's probably not that big a deal because they're both probably going to move approximately the same amount. If the 5-year goes up, you'll make money, but the 7-year will also go up, so you'll lose money. And your 5-year can hedge your 7-year. And hedging costs money, of course, because the hedge means I have to enter the market and trade across the market against the spread and pay a little bit. So you don't want to have to hedge if you don't really have the risk. Principal components analysis will say, well, you've got a lot of exposure to what's called the level of interest rates. You don't have much exposure to what's called the tilt, which is essentially the 2-year minus the 30-year, or the 2-year minus the 10-year. They often talk about in the markets. And you might have a little bit of twist exposure, which is that the bottom goes down, the middle goes up, and the back also goes down. That's a twist exposure. So let's take a look at just a quick run through on the slides. So, you can pull these slides. If you read the book, as I said I think I said the thing last night or this morning, if you read the book, there's a lot of math in there. Even this book does try to minimize the math beyond what's necessary. But linear algebra is pretty tricky if you haven't done it before. Get used to thinking like it, and you can lose the story by trying to figure out how all the equations make sense on your first read. So we're going to we'll kind of, even though I love linear algebra, and I highly recommend that you take it when you can. You don't need calculus to take it. It's not as important maybe as Calc 1 and 2 and 3 even, but it's up there. It's pretty close. It gets a lot of use in machine learning. In particular, it helps you learn about thinking about matrices a lot. You should think about matrices all the time, which really are the foundation of many different machine learning models. Okay, so what we get here. So this is where, if you haven't had a linear algebra, of course, it might be a little tricky to think. The first principal component of a set of features, x1 to xp, is the normalized linear combination of the features. Okay, so what does that mean? Okay, So first of all, these capital X's, the authors are pretty good about this. Each X is a column in a matrix. Just start from, always go back to, we're looking at that Excel sheet, right? Which is, this is our data, right? These are our X's. Every column is an X, okay? And then these are just instances. And the concept, you know, this is based in probability theory, right? The value at any one moment in time of the 1 month interest rate is a random variable. The idea is that this thing moves around, right? And you don't know where it's going to be tomorrow. It's at 352 tomorrow. You're probably comfortable thinking it's going to be, you know, within say 10 basis points of 352. But you know, you don't know really where. You know, we might hypothesize that on average it's probably going to still be 352. But it will go up a little bit, it'll go down a little bit. If you ask where it's going to be a month from now, you probably still think 352 because things will go up, things go down a little bit. But you know, the market moves all the time. As the risks of inflation get more serious, rates will start to rise in anticipation that the Fed will not be able to cut. As the unemployment numbers become worse, rates will start to soften because people begin to think, well, the Fed's going to have to, you know, allow a little flexibility. Of course, the worst case scenario, which we're not quite in, but you know, we're worried. We always worry about this. Goes back to the 1970s, is that the inflation is rising and unemployment's also rising, aka stagflation, which is you can't stimulate the economy to fix the unemployment because it will cause inflation to go up. And I think there's a rule, it might even be the Taylor rule or a version of the Taylor rule, which says that the Fed should probably be twice as worried about unemployment as it is about inflation. Which doesn't mean it shouldn't worry about inflation, just that, you know, if they're going to err on the side of a mistake, it's better that we have fewer people unemployed. Okay, so you got to remember this when we start talking in these abstract X's and P's and stuff, that these are our X's. Every column is an X. So now the idea is we've got, in our case, we've got 1 to 10. P is 10. We've got 10 columns of data, right? And keep in mind that capital X1, when it's in capital X, it's the entire column. When we take a row, we'll probably use like a little x. And we'll use, you know, so little x will run from little x1 down to little x 3000, however many days I've gotten my data. It goes back to 2001, so it's 25 times 365, well, times 250, right? So it should be roughly 6,000 rows, right? So probably about 6,000 rows, 10 columns, right? So now the question is, I'm going to define a new feature as it was. Z1's a new feature. And it's just an average, it's a weighted average of the x's. So on any given day, if I know these fees, or phi's, I don't call them fees right now, then I can compute the z. Right? So what does it say here? So by the way, notice, so there's a z1. Ultimately, you'll have up to p many z's. You're gonna have up to z. Once you have z sub 2, z sub 3, up to z sub p. Once you've got that many p's, that many z's, you can completely recreate the original data set of x's. It's just a matrix inversion, okay? And notice what's happening to the coefficients on the phi. So when you see that phi has 2 coefficients, what does that tell you about phi? As if it's got 2 coefficients, what kind of object are we going to need to represent it? And the correct answers are either vector or matrix. Pick one. Go ahead.
No, matrix.
It's matrix, right? If it's got 2, it's going to be a matrix. If it's only got 1, it's a vector. Okay, beyond that we call it a tensor. Okay, 3 or more. Okay. So every z is going to need p coefficients. So what this says is this new z variable is going to have a weight phi1, a weight phi2, and all the way up to a weight phi p. It's going to have p many weights. Let's use p equals 10. There'll be 10 weights that will, so when I want to compute the z, I take all of those columns and I just multiply the entire column by the 10 weights that I pick. Let's just say, for sake of argument, that my weights are, 1, -5, 7, 2, 15. I got 10 weights for my z. Okay, so that if I knew those 10 numbers, I could take the original Excel. Let's just go ahead and do it. we'll do it very quickly. You know, I could do the following. I could say, look, let's just say the weights are, I'm gonna put in random numbers here, equals ran, that'll be good enough, okay? Command R, Control C, let's go over here. A, we get 10, I got 11, okay, I don't really need 10, let me Control C, and edit, any special values, okay? So I've got these 10 weights, okay? And what the principal component method, the first, you know, this, what does this Z look like? And I want you to see this, so you can get a feel. Okay, and over here, we'll put the date. Okay, and then over here, we'll put this weight, which I'm going to stick with times. So now I've taken so for that first row of data, I've gone ahead and I've okay. So these are and keep in mind, one last thing. If you look at the formula, right, Z1 says you take all these phi weights. I've created 10 weights, phi 1 to 10. Ignore the second subscript on the phi because that just means we're doing Z1. We'll have to do this again for Z2, right? Take those weights, multiply them by the original variables, the x's, the 3-month, the 6-month, the 9-month, and so on, and then add them all up. So the z is actually the sum of these things. So this just says the z variable on the very first day is 26.
And that's Z1.
That's Z1 on the first day. So Z1 there's going to be a Z1 for every single day. Just like there were X1s through X10 for every single day. Now I figured out, having assigned these weights, I figured out what the Z weights are. Well, I figured out what the weights are for Z1. I've multiplied all of the X's by the corresponding weights, and I've summed them. That's my Z1, right? And then to get Z2, right? Every once in a while, one of my hotkeys will work. Let's just see. Shift plus. I like that. Okay. Let's just do it again. Equals rand. Okay, get another random number. So rand gives you a number between 0 and 1, uniformly distributed. Okay, Command R. I'm going to save it, and I have to paste special. Okay, paste special values. Okay, and then my Z. This is my Z1, right? Okay, my Z2. Oh, I did that one. This was Z1. This is going to be, so for Z2, right, I'll just hack this a little bit. Let's grab this guy. Now, you know, Excel helps me to see what's really happening. I'm going to do equals here, same date. And now I want to take the Z2 variable, the coefficients in that linear combination. I'm gonna anchor that. I'll fix that in a second. I need to anchor in the 11th row. Okay. All right. And then I want to do the same thing here. And this is Z2. And I just need to drag this guy down. So now I've got Z2 variables, right? And I've only done the first 10 rows or so of each one, right? But now, so now I've got Z1 on the, it has this time series. Z2 has this time series. We do this for Z3. Now the only thing I haven't done yet, let's go back to the formula. The formula says one more important thing, which is I get these weights, however, by the algorithm, which we'll get into. I get these weights, and once I have the weights, I can multiply all of the X columns by the weights, add them all up, that'll give me Z1. And I do it again for Z2, Z3, and then in the end I could have up to 10 Z's. One restriction is the fees have to be normalized, which means their size is 1. This is their Euclidean size. A squared plus B squared, you move to more dimensions, plus C squared plus D squared, and so on. Add them all up, square them, and then take the square root to get the size of it. But you don't need the square root, it's going to be 1. So square root is 1, the number's 1, right? So that's what we want to do, right? The algorithm will do that for us, okay? And then what we have is new variables. And then why would we even care? We've got, this is where we've already got, we already know the whole set of interest rates. Why would I care about these Z variables? And the working idea is that the Z variables, you maybe only need 3 variables to represent the 10 variables that the X's are required. I.e., most of the information in that whole 10 by 6,000 data set is incorporated in really only equivalent of 3 columns. And we want to focus on those columns and what they can tell us about the market. Okay, that's what principal component analysis is about. An example of how principal component analysis is used elsewhere is when these Voyagers were sent out to outer space to take pictures of the distant planets. They would send back their information, and what they sent back, maybe their pixels were 240 by 240, whatever the transmission and memory capture would allow. They wouldn't send back all of the 240 pixels. They'd instead send back principal components of the pixels one at a time. And as each new principal component came back, the scientists at NASA could reassemble the original picture by inverting the principal component process. And so at first they'd get this kind of blocky looking picture, and then another hour later more data comes through, and eventually they could get all of the components back, and they'd have the full, you might as well get them all back in case of pictures, because if you're not going to see all those components, why would you bother to take them, right? You'd be wasting them. Well, these are big scientists, they know what they're doing, right? So you'd see over time, the images would become more and more refined as more information was captured. And that's a lot of that, kind of interesting, becomes what happens in a deep learning vision model, right? You've probably seen pictures of Tesla driving around on the street with its camera, and a lot of its information, they have a picture of a person, right? It's just like this orange blob, right? Maybe with shoulders and a head, right? But they don't need to have the hair color or the eyes. They need the critical information like that, right? Okay, so vision models that work like that. Okay, so that's what we're doing. That's where we'll be soon. And this is the algebra. Okay, this is the thinking. And then, okay, now, how to compute them? Well, let's look at our paper first. So what are we going to talk about in this case? So you can read through this. Wonders of Google Gemini is my current AI of choice, because they gave it. Everybody have Google Gemini for free, right? Yeah.
My question, should I start with this? Why are we starting with PCA? Like you went straight to chapter 12. Why didn't we start at chapter 1?
Well, you've already covered much of the first 6 chapters topics with Professor McDonald, but in R.
And that basically.
Yeah, so I don't know how much he referred you to the book, but the book covers linear regression, covers logistic regression, covers the lasso, covers the ridge,
Mm-hmm.
covers the elastic net, covers the
Random
AUC.
forest.
What's that?
Random forest.
Which is,
Random forest is in the book.
did you guys cover random forest?
He hasn't done that.
No, it's covered in, it'll be covered here. We're gonna do trees and then from there forests. So those topics are already covered.
Oh, okay.
So we're not doing linear regression, we're not doing
Gotcha.
logistic regression, we're doing other
Gotcha.
topics. Why I'm starting with principal components analysis, different reasons, it's an interest of mine. It's actually an important concept in risk management because it can be used in many ways. It can be used for VAR, and it's a nice place to start, particularly this interest rate concept. So we read through the notes, a couple of things we'll find. So we have interest rates. If we're doing risk management, we aren't really, from day to day, we aren't as concerned with the level of rates. We don't really care whether it's 5% or 3% to the exposure of our book. Because our book, we want to know what happens when the rates change by 1 basis point, let's say, right? So the first thing we do is we take differences. We're not going to do this code. We're going to pass all of the code to a Python method, and in a later part of the class, we'll get the whole Python environment going. But I wanted to have
Looks
a.
like time series.
What's that?
That looks like time series.
What's that?
That looks like time series.
Yeah, this is time series,
Oh,
right?
okay.
We're taking first differences because yields are already expressed in, as they say, to ensure the data is stationary. That's always the reason. I had a friend when I was working at GE with Professor McDonald, and he said, I always take first differences before I even get started. And in finance, we do it all the time, right? We're interested in the return series. We're not interested in the price series so much, right? We take a log of the returns. We do logs because continuous time mathematics is kind of the standard, more common standard, right? In this case, for equities, we did this return. I don't know that I would have probably gone with logs. I had GPT do this for me, so I had Gemini do this for me, so I'm good with their method for now. It doesn't really matter. But the point is we are interested in the changes. So the original X matrix that we were just looking at for interest rates is not going to be, we will give that to our model as input. The first thing the model will do with that is convert them into changes. How many points did we change by every day, right? So, pulling back up the spreadsheet, the first thing the algorithm is going to do, it's going to say, it's going to say on this day, the interest rate was 365, which was 2 basis points lower than it was yesterday, right? Okay, that's the first thing. And then the second thing that usually happens, although it's not discussed in this paper, is that we typically subtract off the mean after we're done. So we center it on 0. So we take all of these data points, right? We take all of these data points, and we get the equals the average. So that's the average, and then we would take the existing value and subtract the average off from every data point, okay? And these would be the new numbers that we try to, that represent, so that's our first column of data. We do the same thing for all the other columns. And now we have 0 mean column vectors. And the reason for 0 mean is the rationale behind principal components analysis, which was started in 1904, apparently by Carl Pearson, kind of like the father of modern statistics. He created the Pearson correlation coefficient, which is the one we use most of the time. And the idea is, going back to our, let's see, our picture here, is at this line, we recognize that most of the information about those points is where they lie relative to this green line. if you tell me their coordinate on, now think of the green line as being a new axis, because that's what principal components are, they're new axes. Think about this being 0, 0, the origin, right? So what we do when we do a principal component analysis, we express the purple dots in terms of the coordinate system given by the green and the blue. And in particular, we might say, you know, the only thing that's really important is where it is on the green. Imagine this data being compressed much closer to the line, right? Then you would just say, I really just need to know the green coordinate. The red coordinate, the dashed blue line coordinate is just kind of noise in the model. I'm not going to worry about that, okay? So how do you, what's the mathematical formulation of this problem? It says, look, take all of the coordinates that you get along the green line in such a way as to maximize the variance. So you want to pick a dimension where this thing is spreading out the most. So, you know, ask yourself, is the biggest source of spread the height on this XY plane, or the width here on the XY plane, or is it, let me look at it this way, and it's the position relative to that green line which has the highest variance. And the linear algebra problem that finds that green line for us solves exactly that question, which is measure all of those XY ordered pairs as Euclidean distance, that is Pythagorean distance, to any possible green line. Find the green line that will make that sum of distances the maximum, i.e. gives us the most information. It tells us, you know, telling me a lot. If you can tell me, like if you can only tell me one number about this dot right here, what number should it be? Should it be this 20? Should it be this 2.5? No, if you can only tell me one number, principal components analysis says, tell me what this number is relative to the green line. So the green line, which has a 0 over here, maybe this is like -17 on the green line. It says, you tell me that -17, and I can basically get back to this 20 and 3 coordinates. That's kind of the philosophy of this, okay? All right, so, like I said, we might end up with this for 2 weeks. We're going to look at interest rates, and we'll also look at it for equities. In equities, so in interest rates, the 3 principal components that typically get used refer to the level. Are rates 5% or 3%? I'm sensitive to parallel shifts in the yield curve. They refer to the steepness. Am I sensitive to the front or to the bottom changing? Like what happens when you're going into a recession, right? The classical warning of a recession is when the front end becomes more expensive than the back end. You can actually see that very clearly in like 2022, I think. Right? And then the last one is the twist. Less information there, but still useful, which is the relative value of. A lot of people like to put on this trade where they buy a 2-year bond, they buy a 10-year bond, and they sell 2 5-year bonds against that, so that they're neutral to parallel shifts in the curve, but they're betting on the twist. That's a more refined analysis. Certainly the 2 minus 10-year spread is a much bigger one, right? Which is, I think if the world's getting a little softer, I think the Fed's gonna have to cut, but if I think it's gonna be inflationary, maybe the back's gonna go up. And you know, rates traders trade these things all the time. In equity markets, it's more interesting. What do you think the first principal factor will be in equity markets?
Share price.
What is it?
Share price.
Well, what we have like the entire market of share prices. So what we're really trying to measure is the change in the change of every share price. Let's use the S&P 500 as our 500 columns, let's say, right? So what's the one thing that unites all of those 500 column prices?
The index price.
What is it?
The index price.
You know, or as it's more commonly referred to as the it's a Greek letter. It's not alpha.
Beta?
It's beta, right? It's the beta. The market, the sensitivity to the market, right?
Oh.
The first most interesting thing about any stock from a point of view of investing and understanding the risk is how does it react to the market, right? If you buy NVIDIA, you're like, okay, it's gonna have a beta of like 1.6 or something. Which means if it's a good market, it's good to be up NVIDIA, but if it's a bad market, probably not good to have the NVIDIA, right? Okay? Now that's the first factor. And what's the second factor? I think the second factor, it's on the next page, but we'll be there in a second. after beta, you hear them talk about this all the time. The next, after they give you the S&P did this, NASDAQ did this, what's the next thing they start talking about? Why did the S&P do this today?
Volatility?
No, they talk about
Well,
the financial sector, had a great day because Goldman reported good earnings. And the tech sector was strong because Oracle reported after. They talk about the sectors, right? So you got your tech, your pharmaceuticals, your consumer cyclicals, your defense stocks, your healthcare. There's like 10 sectors that are kind of prominent. And then the third thing they talk about is one of the famous themes of University of Chicago circa 1980, 1990. Found the French. This was one of the first things they said, about the efficient. Why, for example, why is Warren Buffett so great? What's his real specialty? What's the word that he always is able to find? Value, right? So there's value versus growth, right? So you buy stocks with sensible PEs, you're a value investor. You buy stocks with high PEs because you think they're going to go up, you're a growth investor. So then they talk about, and they call it, by the way, kind of weird, I haven't really thought, I haven't traded, I haven't been involved in equity markets in any deep way in my career, but you always hear them talking about sector rotation, right? They're rotating out of tech into defense this week because there's a war going on, right? Or they're rotating out of the high-flying tech sector into the consumer cyclicals because there's fears that this. Turns out that rotation really means you're giving up one of your principal component exposures and putting another one in. You're looking at that second principal component and you say, I got too much of the tech part, I need more of the equity part.
so rebalances.
But rotation is more than just rebalancing. Right? It's a choice of where am I going to weight my stock. I'm going to go with the defensive stock. I'm going to buy Walmart. I'm going to buy Budweiser, I suppose. Right? So then there's some stories on the math here. I don't want to bog us down in it. A whole nother course. But you do need the covariance matrix, which is you take the x's which have been demeaned. That means the mean is 0. They don't say it, but they have been demeaned. And the reason why you don't need the mean is because you're only interested in the variance. What do you do when you take the, how do you compute a variance? The first thing you do is you compute the mean, and then you subtract the mean off of every element. So we start right away by just, let's get rid of the mean right away. And this t minus 1, t is the number. This is a weird use of the t. I should have flagged Gemini on this. Because this t is for transpose. That other t is the row. By the way, matrices always rows come first, columns come second. Don't forget that. Rows first, columns second. I usually use M and N, but the book uses N and P. So for this lecture, we'll talk N and P. But you need the covariance matrix, and then something you learn about in linear algebra called eigenvalue decomposition. You do an eigenvalue decomposition, you get these matrices that multiply to give you the original matrices. It turns out the principal components are the column vectors of Q. That's the algorithm, and Python will do that for us. Specifically, the sklearn library will do that for us. Okay, so let's go see what we get. And then there's a little summary here. We're going to go to pictures because pictures are more interesting. Here you can see beta, rotation, and this is growth versus value. In terms of interest rates, parallel rates, I don't know if I would call that one, I guess that's called twist. I guess it's 2 year minus 10 years, the twist. The butterfly is the two ends versus the middle. Okay, so let's see what we have here. Now I put this nice caveat here, which tells you in red, Gemini did the work for me, did the code, gave me the results. I looked at the results, it looked pretty good. I said, tell me what you see, and then I had to guide it to, the first factor is considered relevant. What was interesting about these decompositions, well, let me go to the picture first, actually. So this is what's called a scree plot. So what we have here, remember we had 10 columns, so you can see I end up with 10 principal components. And what the scree plot, as this is known, it's often represented as dots connected by line segments. Okay, but I like it better as a bar chart. What this says is that 81% of all the variance in the data of the covariance matrix are explained by the first principal component. That Z1 that we were computing explains 81% of what's going on. The PC2 explains 9.1%, and PC3 4.8%. So you get a total of, at that point, you're at like 95%. And then these other 5 guys explain the other 5%. It will always add to 100, because if you have all the principal components, all you've really done is relabeled your axes in a weird way. It's like taking the grid of Manhattan and dropping another grid on it that's at 45-degree angle to the original grid. You can still find yourself by using the original coordinates. And if you know how to reverse the process, you can say, you know, in old coordinates, I'm on, like, you know, 47th Street and 8th Avenue, right? It'd be no big deal to take the grid of Manhattan and just put a different grid on it, right? And you could say, you know, longitude and latitude, right? That's a completely different grid, right? You know, you can, both of those things exist, and it will be, in this case, a simple linear transformation, okay? But what's interesting, now I've looked at this a few times in the past, like rates haven't been my thing either. I've been doing commodities for a long time, FX before that. But it was always the case that I thought the first 3 principal components were like 90 plus, you know, 7 plus 2. Like already you're at 99. This data did not quite get to 99 in 3 components, 99% of the variance. And we'll see.
So Professor,
Yes.
what was the weights then for each of those x? So what was the slope for each one of them?
So the weights, so
It's the x are the columns, right? So then what was the phi or the phi?
right,
For
so
each one of
we would get, right, we could actually get them out of the model if we wanted to. But it would be like it's a linear algebra problem. It's just, it's this same thing I told you about with this, you take the map of Manhattan, right, and lay another grid over it using other coordinates, right? There's a way to get from the old coordinates to the new coordinates, but you gotta do some linear
Sorry, so
algebra.
you're saying basically the slope was calculated using linear algebra? Is that how it was calculated?
All of this is done using linear algebra algorithms, right?
Okay. I'll be curious to see, okay.
Are the fees arbitrary, or is this something that you created?
No, the fees are selected to optimize the amount of variance that you capture, right? If you pick,
Gemini is the one that applied.
well, really Python, the Python code, there's an algorithm for doing it. Remember, the real goal, right, is we want to get the, what's the slope of that green line, right? In one respect, there is no slope. In the new variables, it doesn't have a slope. It's just the x-axis. And in the new variables, this is just the y-axis. But in the case of thinking back to the old variables, there is a slope here. It's like basically, what is that? That's 5 on the x-axis and 30 on 30. So it's 30 over
60.
40, let's say. So the slope of that green line is approximately 0.75. Right? And so it'll have 2 coordinates that represent the change in x that occurs
Right.
per change in y, and then normalized to be 1. What does normalized tell us, right? Like, let's just say, let's use the example which I gave you. So let's just say, so let's say that delta y happens to be 3 and delta x happens to be 4. So what would the principal components be? This line, the z1, would be equal to 3. Would be 4 over 5 and 3 over 5. And the reason why I divided by 5 was so that their square distance would be 1, right? We get 16 over 25 plus 9 over 25, 25 over 25. So this vector, the length of this vector is equal to 1, right? And then the other vector has to come in here, okay? And in order for this thing, so we didn't talk about this yet, but let me highlight it now. We have to, the new axis has to be perpendicular to the first axis. In fact, the condition that we apply to the second principal component is it has to be orthogonal, perpendicular to the first principal component, and it has to maximize the variance that's so far been unexplained by the first component. And if we're only in 2 dimensions, you get all the variance that way, right? And so it turns out, in order for, given that we have this, the second number will end up being something like this. We're only in 2 dimensions, and we take, the dot product of these two. We get negative 12 over 25 and positive 12 over 25, which is 0, right? So this vector is orthogonal to this vector, okay? But the algorithm will pop those out. It's designed, the cues that we saw in that matrix decomposition of x transpose, or x transpose x, the algorithm that produces those cues automatically produces orthogonal vectors, okay? Okay, so we'll take a break in a few minutes. Let's just see, before we break. So what this coding exercise will, what's going on? What this coding exercise will do a couple things. I'll give you the data for this one, but you can also get the data. It's pretty easy to write code to get it. It's not easy to write it. It's easy to ask Gemini to write it for you, obviously, right? This was the first 5 years of the century. Then 2005 to 2010, incorporated the great global financial crisis. There was actually a pretty big decomposition here where you can see that the second principal component took on a lot of importance. You can see, whereas in most years we'll see that this first number is in the 80s often, right? And the second number is like 10. This time they went to 61 and 26. Now, by the way, I have the data. I didn't independently do the calculation. I'm a little suspicious that it's this egregious, but for now I'm just going to assume, and that's the statement in red. All of this was done by Gemini. Yes, the AI can do a lot for you, but somebody needs to take a look and say, yeah, it's good, right? And it makes sense to me. So that we get, you can see in the aftermath of the financial crisis, the third principal component, the first principal component, back up to 86. This is actually the high of the period, and then we get the fourth principal components. So we get that for 5 years, and then we get down to equities, and the equity scree plots. These are the weightings, right? They show you that the first principal component is the level, and these are the. This is. This is still interest rate. Sorry, again.
Is it always the case that Z1 it does the most explain?
Yes, it has to do the most. That's when you solve for Z1, you are looking for the one that will do the most explanation. It explains the most variance.
So PC7, Z7 will never.
They're always going to be ordered 1 to 10 in that order. That's what the algorithm baked into the algorithm. Well, the algorithm that decomposes the correlation matrix into Q, lambda, Q. That just gives you the columns in random order. But the eigenvalues that are associated with those, the lambdas as they're called, will tell you which ones are going to be the most important, and then you just rearrange the columns to fit that. So this shows you what the interest rate looks like. So these are the tenors that we put into the model, 1 year, 1 month through 30 years. The first principal component has weightings. This goes to your question earlier. What are the phi 1, right? And you can see what does phi 1 consist of. For phi 1 is 0.05. Phi 1 number 2 is point. So these are all of the Z1 weights. for each of the 1010. These are the Z2 weights, these are the Z3 weights. So these are all of these numbers here, so we see 30 numbers here. Of course, there are really gonna be 10 numbers for 10 Zs, so we'll have 100 in the end if we show them all. So the first one shows you, the thing to notice about the first one is they're all positive. What this means is every tenor responds the same way to the level. If rates are going up, they're all kind of going up. If rates are going down, they're all kind of going down. That's what the first one says. The second one you'll notice has this very pronounced, this is positive, this is negative. Turns out the positive negative could have been flipped. The eigenvalues are only identical, are only chosen up to a sign. So if we picked a negative eigenvalue instead of a negative vector to go with the eigenvalue instead of a positive vector, that would just flip the orange bars. I think our code actually said we'll always put the positive ones first. But you can see that this is the 2-year going up and the 10-year going down. Okay, and then you can see it kind of in the middle doesn't change that much. And then this one's the twist. This is the 2-year and the 10-year going up and the 5-year going down as a part. And those are the 3 principal components. Okay, that's enough talking for a while. Let's take like 15 minutes. So let's say 8, 10 or so. We'll start. And I'll put up some things you can start while you're sitting there. How many people have PyCharm? Cliff?
VS Code.
I downloaded Anaconda.
You did, good. Okay, so you're going to want Anaconda. You're also going to want PyCharm from JetBrains. And PyCharm is what's called an IDE, and we'll make a lot of use of it this semester, this half semester.
PyCharm is in Anaconda, but the first time you run it, it's gonna say there's nothing
PyCharm is
installed.
okay. You can just search for PyCharm, download it, it'll come up, or you can go to JetBrains.com, either one.
Should I use the one in the Anaconda Navigator? 'Cause it
No,
says PyCharm.
I downloaded, I'd go for a separate PyCharm.
Okay.
I say that because I haven't used the one, the Anaconda Navigator, so, I don't know.
Well, it directed me to JetBrains.
So they're just helping me find it. That makes more sense.
So, Professor, another question. Like, why was it over 5 again? I'm sorry. When you were showing the slope, you had 3/5, 4/5. Where did pi come from again?
Well, so I just did the regular slope, which was 3/4.
Right.
But the requirement is we want to normalize
For it
the
to equal
vectors.
1.
Normalize means to set the distance equal to 1.
So
So you just divide by 3 squared plus 4 squared,
Okay.
every component, and then you get something that will add up to 1 each square.
Gotcha.
I'm going to send you a bunch of code.
Okay.
Yeah.
That's where I.
No, it should, but that's why you're here, right? You want to do more coding, right? Let me just get the code. Send.
I got the book example to work last night.
What's that?
I got the book example to work last night.
Hold on. What's it?
I said I got the book example to work last night.
Oh, good, good.
Did you try this one?
I haven't, but I'm sure it works fine. Stop and rerun's fine, yeah. You can hit the red, stop it. Oh, it's still cranking. Yeah, nice.
It makes that, then
Yeah.
you close it, it makes the,
Yeah, gotta close it to see that.
which is kind of annoying.
There might be a way to make it not do that. Actually, I ran them, when I did the pictures that we saved.
Spider puts them next to each other and you can just pick them up versus Jupyter. I did it in Jupyter first because I always do it in Jupyter first.
Yeah.
It just works.
Yeah, but leave Spider behind. You'll never regret it.
Well, that was Yakov's favorite.
Yeah. I used Spider for a long time.
But if you put this into Anaconda, it doesn't have pandas, it doesn't have MPy. So the first time you run something, it's got to import all these things. They're not loaded automatically once you come from Anaconda environment.
Yeah, but that's actually a good thing. And I'll tell you
I know,
why.
but there's different versions.
Well, first of all, in a file, you always need to do the imports. The one thing that will happen is if you import some other library that you don't have yet, you'll actually have to download it for the environment that you're in.
Yeah.
But that's a good thing, because if you don't the environment package manager, Conda in our case, or PIP, controls what you let in and what you don't let in, and it keeps track of which versions of each different library will work with other libraries. So
Some of the stuff in Jupyter, you had to pip into it.
Yeah, you
It
can
doesn't
pip-
come
exactly.
Didn't come naturally installed.
yeah. Well, nothing. The pure way to start is I have Python. Okay, now let me create an environment, and that environment you'll say which version. All you got to really tell is which version of Python do you want. Right. Once you have that set, you can now start You can start installing.
You can actually make environments through Anaconda too.
Yeah,
I
you
found
can.
this out. They told
Yeah.
one of the AIs told me about this.
Yeah, and you can see it too.
And you can make them all your own. Like
Yeah.
if it tells you need this version and that
Yeah,
version
yeah.
of NumPy or Pandas,
Yeah.
whatever you're doing, you can make separate. But it broke my regular Python. I had to redo the whole Anaconda thing afterwards.
Yeah, exactly. So what do you got? You got PyCharm?
Yeah, it's,
Okay.
I just got it up. This is all foreign to me. I'm a VBA guy.
Yeah, but you can learn.
Oh, no, that 100%.
That's why we're here, right?
So my question would be,
Yeah.
and I asked Professor McDonald as well, like he couldn't help so much with R. Where is a good like store of knowledge that I can learn Python?
There are many.
One that you think are reputable.
Yeah, no. There's many good choices.
Data
I
Cube.
would ask Gemini for the best first Python book. Let's say what comes back. It's probably going to be an O'Reilly book. But before you go further, we're going to go through the code that I distribute tonight, and we'll talk about what it does, and then you can read up on it. Like so, have you had other languages besides VBA?
VBA is the only one I learned.
Yeah, so like every programming language book, they will have, the first thing they'll talk about are data types. They'll say, it's got an int, it's got a float, it's got a string. Those things are all common to every language, but sometimes slightly different in every language, which is why they talk about it. Other aspects like loops, you know what loops are?
I understand, well, the biggest thing for me is just understanding the syntax. The way my brain works is I've always got to understand why.
Sure.
I don't know why I have to do it and not just take it for face value. Like,
Yeah.
if you tell me do X, I need to know why I'm doing it.
Okay. Well, we'll see where we get.
Look up Data Camp.
Say it again?
Look up Data Camp.
Data camp?
Yeah.
Yeah, data camp is good.
It may cost money. I don't know if you can get it free through the
Is that
store.
like a
but-
boot camp?
It's a website that provides a self-oriented bootcamp type experience. So,
I'm gonna have my wife buy this for me. There's a Father's Day coming up at some point.
yeah, but don't buy yet until you get a handle on what's available.
Got it.
Well, they
Do
talk
you have Gemini
Python.
for free? Gemini Pro, right, for free to students, yeah?
Yes.
1 year free, right? I had to wait until my regular, because I was already on Google Pro, $20 a month. So every time I try to sign up with Gemini, I have a student ID from Bergen Community College. Every time I try to exercise my free year, it would say, you gotta wait till, you're already on a paid account, we can't let you go. So I had to cancel my paid account. I had to wait until the month that it was on ended, then they, yeah, okay, now you can create it.
That's so bizarre.
Yeah, it's pretty funny.
So far, I've got away with just the free ones.
What's that?
So far, I've gotten away with just using the free versions.
Well, you know, the Pro is the Pro, and it's free.
Okay. PyCharm, double shift everywhere.
I like Grok.
Welcome to PyCharm. Okay.
So a popular class is Harvard CS50P. So they have it's a CS50 is a class that almost every Harvard student probably takes. It's elective, but their P version is free. They used to teach it with Scratch or some other kind of, in theory, great for learning language, but at this point, just learn Python.
So Harvard CS50P, I'm assuming P stands for Python?
Yeah, exactly.
Should be on YouTube. I
It's
think I've
free.
seen that.
What?
YouTube is, I think I've given so much time to YouTube I basically live on YouTube. It's like the free university. There's so much information there, you don't know what's good and what's not. That's the challenge when trying to learn.
Well, this class is on YouTube. It's like around 30 different videos.
But a guy like me who knows dick about Python could put a video up there, and because I'm animated, I can get a lot of views. That doesn't mean I'm a good teacher. Whereas you probably know this back and front, but I can't find you. They only find the knuckleheads.
Ed knows it back and front. I don't know Python back and front.
Oh, just back.
I just started playing with Python about a year ago.
So Gemini comes up with this one book, Automate the Boring Stuff with Python, which is available to download free. I always look at O'Reilly as typically the best source of books.
I guess my question is, why Gemini? Because
It was free.
it's free,
I had-
as opposed to ChatGPT.
I had ChatGPT at my last job, my last two jobs, and then the jobs ended, and I decided I was already paying for Google for like storage, and decided I'd rather pay Google anyway, and then it came for free. But it took me probably a couple of weeks where I thought maybe I liked ChatGPT better, but I don't even think about it.
Do you find yourself able to use the same protocols that you would use on ChatGPT with Gemini?
Yeah, I'm pretty much I ask it a question, it tells me the answer, and then I refine it, asking it. A lot of what I do there is code, it's like, give me some code that will do this. Gives me code, I look at it, it screwed this up, or no, what else can we do? So it's fine. Eventually I might get Claude, because it's,
I played with it a
superior.
little bit.
Yeah, Claude is Anthropic's offering for code. Now Claude is thought to be the best programmer's tool, like where you work for a company and they've got 5,000 files in the code base. Claude will read the code base and understand it for you, and then you can start working from there.
You wouldn't want an open source to start looking at all your.
Well, no, I mean when businesses set up, right? They do they have controls around what the AI will learn about what you're doing.
I know at my previous firm, we wanted to start using AI, but we had so much sensitive information, we didn't want them,
Yeah.
because they basically house that information as soon as you give it to them.
Well, no, they're
The Mac
controls,
goes the
yeah.
local, Mac OS only does local stuff. It doesn't use the cloud. That's one of the things complaining about it.
Well, I mean, they have controls, right?
Yeah.
So they have this. They know that they want to sell their services to.
Oh, no, agreed. I'm
Businesses
just
that
saying
have privacy
using-
concerns, so they do control, right?
Using blanket ChatGPT.
No, but even like Google Pro, I asked Gemini Pro this the other day. I said, "Will our conversations leave this interface?" They said, "No." They said, "You can, for ultimate security, you can turn off the memory, but that will diminish your experience with it, because the memory does." It always talks about. So you're going to be teaching this class at UConn. I'll ask it a question. This would be really good to include in your.
Oh, ChatGPT will say, we talked about this about 2 months ago. We asked this question.
Yeah.
It remembers who you are if you sign into it.
Oh yeah, definitely if you sign in. But I've decided I just like Google better than OpenAI for starters.
That's what I love ChatGPT. OpenAI has been the one, but I think that's just because they were first mover.
Yeah, yeah.
But-
But AI can't survive because subscriptions are their only revenue source. Versus,
Right.
versus Google has
I
subscriptions.
also see Google as the winner in that. OpenAI will get absorbed by Microsoft at some point. That's what will happen.
That's
they
where
have the money
Roku
to
went
buy
to,
it.
because
Microsoft does, yes.
But what's the value you're gonna put on OpenAI? What do you think it would take to buy OpenAI out?
he's gonna go broke if he doesn't sell, so it's not gonna make a
750
difference.
was their,
That was their last value.
recent round, yeah.
That was their recent round.
and Anthropic was at like 350 or something.
Well, but that's what I mean. I'm just looking at it from an investment perspective. If I've got somebody like Google coming to me, $750 is no longer the mark. You're gonna have to pay me a whole lot more than $750, because now I know Google's pocket.
No, but they're burning through cash like, I don't know, I've got the number, 12 billion a month or something like that. So they got a problem, right?
Yeah, I mean, their burn is insane, but there are people literally everywhere trying to give them money. So I don't think money is an issue for them.
It's always
Oh,
like,
there's always a point.
it's always
There's
like
always
that
a
until
point.
it's not.
Yes, there's always a point. There's
There's
always a
competition,
point.
right? Claude, Anthropic is is a vaunted competitor. Gemini, betting against Google in the AI space is pretty.
That's very, very tough.
One would think betting against Apple would be wrong, but Apple's been having problems, obviously. But it's not their thing.
I guess I look at it and I say, if Andreessen can still come out with vehicles and funds for them to just like grab people, OpenAI will still have money.
Yeah, no, I think they'll be absorbed into Microsoft. But I don't know.
I believe it. There's only so many people out there that can actually have the money to buy them out.
Well, yeah. I mean, Microsoft is already their partner, right? They had a pretty heavy investment from the beginning. Didn't they give them like $100 billion, $10 billion 2 or 3 years ago?
Something.
They had a deal. They're pretty sizable.
Well, Microsoft has Copilot, and do they want to incorporate OpenAI into Copilot? That'll be the question.
Yeah, I'm sure they're thinking about that very question all the time. Let me just find this. I'm gonna send the file out now, which will have the code. Now, if I had my professor game totally together, we'd have a GitHub repo for all our code, and you'd be able to go there and get it, but I don't have it together.
That's where I had to go to get the code for where I did here.
Yeah, GitHub is,
Because the app that they wrote to download it didn't work, so you had to go to their GitHub page to get it.
send a zip file, I'll be back in 2 minutes to get started. So, I'm glad we did what we've done so far. This kind of covers the finance, at least the beginning of the finance aspect. I really see this course, check. You know, it's about getting your tech skills to be more sophisticated for the competitive workplace in which we find ourselves. And so I take you to a page called TIOBE, TIOBE. Search for the TIOBE index. You'll see, I've shown this to you before if you've been in my classes. It's some company's way of assessing, how prevalent different computer languages are. And it changes every month. It's coming out for quite a while. Looks like it's been about 30 years almost. Python's been at the top for the past probably 5 years or so. I don't know how they compute the ratings. It's just a useful set of ratings. Jives with my basic understanding. Look, a lot of people use Java, C and C++. Everybody's using Python. C# is pretty popular. JavaScript is like the foundation for many websites. SQL, Visual Basic, R, right? Pascal was a huge language in the 90s. It's essentially similar to what C is, but a little more student-friendly. It was a popular teaching language in the 90s. Consequently, it became a big language in business. I know some good software that's running large businesses written in Pascal. And it goes on. Rust coming up as the next C++, it's safer. Fortran's still there, and well, Python's been at the top for a while. If you look at the, let me get more languages. If you look at the history, you see that, for a long time, you probably went backwards in time to get some of these other numbers. I don't think it's been running index this long. But Python really just came on the scene in 2001 and it started to make a splash. By 2006, it was number 8. C was number 2. Java had taken over as the large enterprise software of the early 2000s. Still a massive company, created by Sun Microsystems, absorbed into Oracle. C# was Microsoft's answer to Java. It's very similar to Java in many ways, and it keeps you in the Microsoft ecosystem. So Python's extremely popular, and that's the end of the story here. So you want to be in Python, in my opinion, in general. Most jobs that I'm aware of will, hope you can do Python. R also has a good set of fans in the business community, but Python is clearly much more used. So it boils down to, well, what does it mean to work in Python? Forget about learning the language. How do I even get started with Python? My answer is, well, you to be kind of, beyond just like on entry level, I've seen a programming course once. You have to be able to work at least a little bit at the command line, which in Mac is the terminal. On Windows, you can search for Anaconda shell. So go ahead and launch yourself an Anaconda shell. Hopefully, does everybody have Anaconda already? Or okay, well, how do we get Anaconda? Right. So you can. We're going to go even quicker route. Let me get one of the things I sent you. You can use Anaconda, or just as good for most practical purposes is Miniconda. The Miniconda. So many things to me. So I have a couple of versions of this. One kind of key takeaway of the Python environment setup guide. It is why use an environment. A Python environment is a self-contained workspace that has its own version of Python and its own installed packages. So the way any computer language works is there's a core language that you always have access to whenever you're programming in that language. And then beyond the core language, there are packages or libraries, different names for the same thing, where when you need them, you load them into your program so that your program can access those. And the reason why you don't want your core to be too big or too bloated is because one of the reasons is a thing called namespaces. What if two different libraries want to use the same name for different purposes? How do you keep track of which one you want? Well, one of the ways you do is you limit the amount that's in the core, and you load in packages where you know what's coming in, and you get to refer to them. So, what happens when you create an environment? So, if you go to Miniconda, go over here and say, Miniconda download. It's part, Miniconda is part of Anaconda. You just click on the download button, and you gotta give them your address and stuff, right? You'll get Miniconda, right? Or you'll get Anaconda. Anaconda is a bigger universe. Miniconda is mostly just about getting raw access to Python libraries that you then download for yourself as you need. Okay. So if you've got yourself a command prompt, you'll notice that your Anaconda prompt or your terminal prompt will tell you the name of the environment I'm in. Typically, the first one's called your base environment, and you can say, Conda list. Let's see. That tells me that the base environment. I always have to look these commands up. The base environment. Base is just a name. You can call it anything you want. Has all kinds of libraries. In addition to the core Python, it's got Anaconda, it's got ArcSpec. What you'll see, every library, invariably, you're going to need NumPy to be in any environment you work with. NumPy stands for Numerical Python, and it was kind of the improvements to Numerical Python that were made between 1999 and 2004 that really launched Python into the competitive realm of the best, most used languages. Numerical Python, its fundamental purpose is to provide you with a matrix object. You get vectors and you get matrices, and you can do linear algebra type stuff with numerical Python. You also get things like the exponential function, sine and cosine, that are available in the math library for Python. But the real thing you get is a matrix. Matrices turn out to be extremely important for any kind of data analysis, right? What does data analysis mean? You've got rows, which are your users, and you got columns, which are your features, right? Every database looks like that, right? It's got, if you've ever seen a screen of a database, it's tables that consist of some kind of ID number that tells you which element you're talking about, and some things you know about that ID number, which are the columns, right? So numerical Python is that fundamental object, but specifically for numbers. You don't put letters in there, okay? The next one that the most popular one developed not until 2008 by a person named Wes McKinney working at AQR, a big hedge fund down in Greenwich, is called Pandas, which stands for Panel Data Analytics. It's essentially takes the NumPy as its fundamental object, but builds it into a more spreadsheet type object. Its principal object is the data frame, which it copied from R. McKinney would have been familiar with R at that time. R had data frames first. Python copies a lot of stuff from R. So a data frame is, again, it's your basic organization. It's got rows and columns. The difference is the columns of a data frame can have other kinds of data besides numerical data. If you only have numerical data, you can do linear algebra type stuff on that data. But if you have letters and numbers, it'll just be like, I don't know what you mean to multiply a letter by a number. It'll just complain. You'll get an error. And then there'll be all other kinds of stuff. Pip is a popular package manager. When you want to install libraries, your two choices will be to, from that command prompt, say conda install and name the library you want to install, or pip install the name of the library you want to install. Both of them are useful. Sometimes only one will work for a particular package. And they'll always have a Python. The fundamental program, the core library, is accessed by running python.exe. On Macs, it might be called, you might have to type Python 3 to get it to run. But either way, when you do that, so I'll give myself a new window here, right? New window, motion, right? So So you can see I'm already, again here, if I type the word Python, it launches an interactive Python prompt. Not that useful, but it's useful for demonstration purposes. What can you do at a prompt? You can do 3 plus 5. It'll tell you 8. You can tell it to print, and print you have to surround it with parentheses, and you print a string, and it'll print that thing. I could say, my name equals Ed, and I can say print, hello, space, plus, I think this will work, if I'm not mistaken, my name, and get hello, Ed, right?
I'm pretty sure I did something wrong.
But,
Pretty sure I did something wrong. Something
Okay.
saying PowerShell is not recognized as an internal or external command.
yeah, so let's see. Okay, no, but that's okay, don't worry about that.
Oh.
You're there. Okay. That's, you can always take those comments and cut and paste them into Gemini or ChatGPT, and it's pretty good at telling you what's going on, which is really the first big labor saver, right? Used to be you'd have to go to the internet and search around for 20 minutes to find an answer, maybe answers your problem. Now you just tell the computer, you tell the AI, I got this error message. It says, oh, that's because you're doing this. Here, do this instead, and then boom, you're fixed, right? Okay? But there's, this is an interactive environment. It's kind of fun to look at, but it's really not that useful. So I'm going to Command D, I think it's now, I'm going to Command Z. I guess I just want to type exit and out, right? Okay. So we got a lot of libraries. So what we'll want to do in this class, and this is in one of the handouts I gave you, we'll want to create an environment. So how do I create an environment? Well, I could ask, how am I going to do it? Well, I'm going to do the old-fashioned way. I'm going to ask AI. I want to create an environment. You just say here, command to create Conda environment. ENV. It's good at understanding abbreviations. And it'll give you a good story. It'll tell you can pick your version of Python. Conda create dash name builds an isolated directory, Conda activate, Conda deactivate. So I'll go over here and say Conda create dash name, should copy it, right? Dash N, give the name. So dash N, and this class is, finance, 5331 this class? Okay. Okay, so I've created an environment, and it tells me some stuff, but do I want to create this thing? Yeah, I'm going to create it. And now I've got an environment. So now if I do Conda list, it'll tell me, I want to do Conda ENV list, environment list. You'll see I've got a few environments. I had the base, which we were working in. I've got some other things that I've done before. And now I've got one called FNCE 5331, okay? So I should be able to just Conda activate FN. Sometimes command completion will work. Okay, so now I'm in this environment. Now I can do Conda list. So now you can see there's no packages in this environment. It doesn't even look like it has a Python. Let's see if I can run Python. I'm pretty sure I can do Python -v for version. And it doesn't like this. It doesn't like that at all. Okay. Okay, so I did Conda create -n FNCE. It's good to tell it what you're doing because you'll remember this stuff. What Python version did I get? I didn't get a version at all because I didn't specify Python, create a completely empty environment. If you act that in, then your computer will blah, blah, blah. Okay, so list is empty. Okay, you don't have to delete the environment, you can simply install it now. So let's install 3.13. Okay, so just just click on the code, I copied it, and, here, it looks like it did actually bring up a Python, so it's kind of wrong. Unix is a little weak to kill a process. Unix people are pretty tough, they kill processes. So I'm gonna install this into my environment. Now, I asked it to install Python 3.13, and it tells me it's gonna give me more stuff. It's gonna give me some of this stuff that will be downloaded, and the new packages will be installed. Most of which is just Python and pip nothing. I get an SQL thing here, so tell it yes, and I always trust the gods of the internet to not do me wrong in this case. So, now, let's see. Okay, so we've created an environment, and okay, there's a couple of I'm already on option 2 here in Mini Conda, and I've activated it. And okay, so install requirements.txt. I'm not going to do that right now. I could have created a file called requirements.txt, run this install command. It'll read everything in the requirements and just go ahead and install it. What I'm going to do instead is I'm going to do just a bit. I'm going to do conda install NumPy. And it says, you ready to go for this? And I'm like, yeah, you know what? And conda install pandas. I said these are the 2 most popular libraries. So get that. If I do pandas first, it would have gotten NumPy for me. Okay, now I'm going to do one more. The primary library that's used for non-deep learning models is called sklearn. It's short for scikit-learn. It's got all of the algorithms you've learned so far, linear regression, logistic regression. It's got trees. It's got PCA, as we'll see. And I guess I got to tell it. And it's brought in as sklearn, but you got to tell it. You got to call it scikit. This is going to fail. Let's ignore that one. Hold on a second. How do I get sklearn? Here we go. Scikit-learn. I put the hyphen in the wrong spot. I don't really need to tell it exactly the way it did because I'm already in this environment. So scikit-learn. Am I sure? Yeah, go ahead. And if you run this thing at your Anaconda command prompt on Windows, you get all the same verbiage. Are you sure you want to do this? You just hit. By the way, when you see this proceed, Y in brackets, no. It tells you that the brackets is the default, so if you just hit enter, it does Y. Because now I've got, if I look at my Conda list, you see I've got a lot more libraries in, not too many, it's actually pretty slim. Okay, so one goal for the next 2 weeks, let's say, I'm not sure if I'm going to teach in 2 weeks or Professor Rubin. He's got one more class. It'll probably be next week, possibly be the last week of the month. We're working that out. He helped me out
Isn't spring break next week?
Next week is spring break, so
So the week
next
after
week
that.
is the 24th, yeah. Okay? And I'll send out I'll send out queries on how you're doing. If you're gonna wanna get PyCharm going, you're gonna wanna get, your goal will be that you get this code that I sent out a few minutes ago in a zip file, working for you.
So why do you recommend PyCharm over VS Code or other?
You can use,
IDE?
a lot of people use VS Code, but mostly because it's free. I don't know why they, and you can use it with many languages.
Yeah.
But I have turned young interns from VS Code aficionados into PyCharm users in the end. When I was learning Python, Spider was my default IDE. I used it for a lot of years. I was working with a guy at GE who was a full-time programmer. He was using PyCharm, and I said, why do you use PyCharm instead of Spider? He said, well, it's a lot better. And I tried, it takes a little work to get it to understand what's going on, but once you understand it, it works. And all of the JetBrains interfaces look exactly the same, so when you move to other languages.
So are we gonna use like the Jupyter notebook type of style?
We probably will not use Jupyter notebooks at all, and I'll show you why. We could
Okay.
use them. I mean, you could easily take your,
It's easier to look at.
you can take your file of code and drop it in GPT,
Okay.
and it'll give you back a Jupyter notebook. Like, here you go, drop this in your Jupyter
Okay.
notebook. But I like it for reasons we will see today. Okay, so let's see. So I'm going to show you, what the code looks like. And even I did not know I could do LaTeX, which is the document reduction system that I use today. But the first thing I did was I worked with this would kind of be akin to the way the world looks to a Jupyter notebook person. So if you have PyCharm and you had this code, in theory, you could get this to run. So what do you see when you this interface, right? You have this folder over here. You click on it, you can see all the stuff that's in your code. You click it off so you want to see more of your space, okay? You look at the interface. Why do I like, VS Code, of course, will do a lot of this command syntax highlight. You don't get any of that. Well, you get that in Jupyter too. You don't get as much. The real thing you get that is much more efficient with an integrated development environment is that you can run your code and stop it at different places and inspect what's going on by looking at the memory objects. And that's invaluable when you're trying to figure out how does this thing work. I've even, I've taken topics that involve paper, there's a famous paper from 2001 using Monte Carlo and least squares method to value an American option. I never really had the time to dig through the paper and understand all of the nuance. And then a couple of weeks ago, I was interested, and I said, give me code that does this, and then explain it to me. And it was very, now I'm looking at the code, I stopped it, I said, look, I see exactly what's going on. We have all these numbers, and we're gonna do a least squares representation of what the future looks like. And it just, it's unbelievable. The top of every file, you can put these imports anywhere you want prior to using them. So we're gonna see, let me go to the bottom here for a second. When we finish talking about this, I've got this thing down here called if name equals main, or some people just say dunder main, where the dunder stands for double underscore main. If name is equal to main, load something, do something, and then I do these are the graphs that I created. For a starting year in one of these 5 years, go ahead and do the stuff that's gonna analyze the data and generate those two plots. That's the story here, okay?
Is that file PCA_Fred v2?
Yes.
Is that an environment?
No, the .python extension means it's a Python file, which just means that it's a text file. It's just
Okay.
text. It's just text, but with a special extension. And what that special extension says is if you run Python and give it the name of this file as an argument, it will execute the code in that file. And it will work in one of two ways. If I don't have this if name equals main thing, it probably just starts at the top and runs down. But if I have this if name equals name, so it says if the name is been stored into the main variable when the Python code is running, start at line 145 and do all of these things, okay? And load dot environment, I don't want to worry about that right now. I want to go look at the code. But this is essentially the program. And this program will do the following things. It does a few things, 148, 149, 150, to get set up. It instantiates, and what I'm calling an analyzer. The analyzer variable is an object of type PCA analyzer. So I've written code using classes. I've written, I should say, Gemini wrote and I approved code that uses classes. You ever heard of classes? So what are classes, right? Classes is a concept, it's the fundamental concept in object-oriented programming. Prior to 1980, when the invention of C++, OOP was a theoretical thing that would be useful but had not been developed. There were languages in the 60s, Smalltalk being perhaps the most famous one, which implemented object-oriented programming but never caught on. In the 70s, Fortran and C and COBOL and BASIC were the dominant languages. C was the dominant one for scientific computing. C++ was invented in 1980 by Bjarne Stroustrup at Bell Labs, I think. And the fundamental thing was it took C and created C with objects. And what an object means is you have a template. What does a template mean? It's a machine that you say, hey, give me one of these, give me a copy of this machine, this object. Right? Give me a copy of the class. Class is what you're going to get. And that class will have two things. It will have data that's associated with that object, and it will also have methods that can operate on that, on the data, functions as it were. So for example, I might create a student class, and the data would be all of your names and your student IDs. And then one vector where I keep all your grades, and another vector where I store the weights for the grades in the final grade, right? And then I write methods that say, hey, take all of, go through all my students in my student list, take their grade vector, multiply it by the weights vector, and give me the grade, save it, and then like write it to a report that I can write. So the fundamental advance of the object-oriented programming is using a class where the data and the methods operate together. And the fundamental advantage that this provided was that you could not change the data of a class unless you were part of the class. Okay? Whereas C, you just pass things around, and method functions would change things, and they come back, and you'd be like, why did this change? Where did it change? How do I know? Much harder to debug. That was kind of the fundamental advantage. Object-oriented programming is still the dominant paradigm. There are other paradigms, functional programming in particular, that are competing with it. So if I now here's what this is why I use an ID. And again, VS Code probably will do this too. I can right-click on this object, a PC analyzer, and I can say, well, you can see already I hover on it, and it tells me that when I get to this line of code, it's going to go to the initiator of this object, and it's going to take some kind of data, which is of type data frame, and it's going to return nothing. And what does it say? It performs PCA and generates, that's just the comment. But we can actually go look at that code. If I do my right click, I have my mouse with me, I'd be a little more clever about this one. And go right here and say, go to the declaration. So I go up here, and I see I have this class called PCA Analyzer. So it's just a class that I made. Other classes exist, but this is one of my classes. And whenever you mention the name of a class, followed by parentheses, and maybe followed by arguments, you're saying, I want an object of this class. So when I execute that line of code, I'm going to get back one of these things. And what does that mean? Well, I give it a data frame, and it saves the data for itself as the raw data, and it has other variables that it's going to use. One's going to be called PCA, one's going to be called loadings, one's going to be called filtered, but these are initially set to none. They're not. I don't put anything in them. That means later on they're going to be created. And then down at the bottom again, By the way, so it's the IDE, right? I can shrink it, right? Down at the bottom, so I get one of these objects and I store it as my analyzer. I enter a for loop. This for loop is called, it just says, go over these 5 different numbers and execute what follows with these 5 numbers. The start year is gonna be 2000, the end year will be 5 years later. I create a file where I'm gonna save my data. And then I say, the analyzer, this object that I created, has a method called run the analysis. And run the analysis expects you to tell it the start year and the end year. So I go up here, I right click, and I say, go to implementation. And I see what is this analysis? Okay, it takes every, when you call a method of the class, the first variable is always self. In theory, you could use any other name, but if you use any other name but self, you will be viewed as a sociopath and shunned by the rest of the Python using community with good reason, because you would clearly be disturbed. But you could get away with it. You could put Joe there, and then instead of saying self.analysis, it would be Joe.analysis. So what this says, and what you're really saying is, I may have 50 of these objects lying around, but the one that called you is the one that that I want you to be able to refer to the data, whatever data frame I gave. And it just says, okay, it does some fancy stuff here, but what I want you to see first of all, the yield changes is take this data frame, which has been filtered. I think the filtering just gets rid of, oh yeah, what does this say? Self.analysis years is equal to a string, 2000 to 2005. And then it says, I'm gonna create a mask. Now this is why I like AI, because this is a great way to do it. If I wrote it myself, it would be hard. A mask just says, things only get in if they satisfy the criterion. So this mask says, take a look at the raw data, look at the year of it. And the raw data's index are all the dates. The first column of our data frame was the dates from 2000 to 2025, right? Take a look at the year. It has to be greater than the start year, and it has to be less than or equal to the end year. So the mask looks at every row in the data set and puts a true if it satisfies both conditions. This is Boolean logic, right? This condition is true, and this condition is true. True, true is true. I put a 1. Otherwise, I put a 0. It's too late or it's too early, it's out, right? Okay? And then I say my filtered data frame is take the original data frame, but only take the locations where the mask is true. So what that basically does is it scrolls through the entire data set and only takes the rows that satisfy. Now ours are oriented linearly, so I mean in time order, so it clearly just takes the first chunk. But there could be, mask could be something else. Only take the rows where the 10-year rate is greater than 5%. That would be a different mask. You get this kind of weird set of gaps. You get a few years where it was, and it dropped, and then more pop up, right? Okay? Now I can see that if I want to, right? I can say, hey, look, I'm gonna take a look here. And this again is why we use the, now I can right click here and I can say debug, with the little bug, and it will stop at that red breakpoint. Okay, so let's see what's going on here. So it's already run this code. It came, you can see it, this is where I am. This is called the call stack. I can go back and say, this is where I came from. I got down to this line of code and it says, hey, jump up there to the run analysis method. And I put this red stop sign here, so it stopped there, okay? And now I can look around. I can see, look, what's the data look like? So I can look at self, which is this instance of my PC Analyzer. It had data, the data we loaded in. We could look at the data frame by clicking it over here, and you can see the data is exactly what our spreadsheet had. It's got the 10 columns of tenors, which we're calling our features, and it's got every day. And I'm only seeing the first 100 rows here. And it even does a little color coding thing for me. If I show them all, the color schemes will change. Hey, look, it's, you know, blue is cool here, the low. Hey, the rates are lower versus high. And now, you know, probably something that got really low, and then eventually, you know, they got hot again, and inflation years and so on. Okay, so I can look at that data. Now I stopped here. I can hit this little arrow down here, or F8, which is step over. And now I've got a new data frame. And if you take a look, if we look at the mask, let's look at the mask. The mask is a empty array. Let's say, view the mask as an image. I view it as an array. So the mask is true on all the early years. But if I go all the way to the end, it's false. So that's what the mask did. It said, find the years that are the ones we want to talk about in this problem. And now if I look at the self-filtered data, you'll see that it's a new data frame. Because it's the first set of data, it stops at 2-1. But if we go to the end, you can see the last row is now only, the last row is 12/30/2005. So now I've got the 5 years that I want to study for this particular part of the program. And then what I do, okay, I see if it's empty, it's not. I do this so yield changes. And now what we're doing, so what, first of all, a key thing to note is, what is the filtered DF? When I say what, I'm saying what object is it? It's a data frame. The suffix there gives you the hint. Basically, when you start with a data frame and you have pandas do stuff to it, usually you get back another data frame, right? So I took my raw data frame and I got a filtered data frame. When I execute this line of code, I got yield changes. Let's take a look at yield changes. It's another data frame, and this data frame is, you can see the 2 basis points that we had at the very beginning of our spreadsheet, right? The very first change was 2 basis points. And actually, I don't know if I'm at the top here. I don't know why it starts at 8-1. Oh, these are a European number system, right? Starting at 1-8. No, that's not right. I don't know why it's starting in August. I'd have to dig in a little to find out there. Maybe my data, a little hard for me to understand why that is. How many rows? We've got 1,100 rows. How many rows should we have for 5 years of data?
60. Oh, what's the frequency?
What is it?
What's the frequency?
Well, it's
daily?
Yeah,
So it's probably 250 per year,
yeah.
so 1250.
Yeah, so we should have 1,250. So we only have 1,100. So I guess the beginning of this data is missing. I'm not really sure why that is, but so good. Now, so what happened in this data frame? It says, look, the self, this object that I'm playing with, I just created this filtered method which belongs to this object, and now I apply a diff argument. What is diff? Well, you'd have to go look up how diff functions in pandas to learn that what it does is it takes the differences between 2 consecutive elements of the data set. Okay? And then finally, it does a drop NA. What that means is any place where I got bad information, like there's a missing data point, so I don't get a number, or I got to divide by 0, or any kind of bad data, I'm just dropping it. I'm saying drop that row. So this is what this dot operation is called. This is called chaining. It says take this object, the filtered data frame. Dot means apply one of its methods, which is diff. Now, this method's not unique to my class. It belongs to pandas, which I'm using. And then once you've done that, then apply the drop NA. Okay? And then look at this magic. I say, how many components do we want? And the number of components is going to be 10. It's the minimum of the length of the self-filtered datas.column. Yeah, I don't know why that would be, and 10. I don't know why it would be anything else but 10. And then it does, here's the magic. It does self.pca is call the PCA class. We'll see where that comes from in a second, with the number of components, and then fit the model. And at that point, we've got all the Z's that we need, okay? And then finally, it does some more stuff, and it creates these loadings. These are gonna be the graph. And then finally, it does some more work, it prints things out. Now, these printouts are happening over here. I can see them on the console. The analysis results for 2001 had the level value was 81.2, the slope was 9.1, and the curvature was 4.8. Just kind of giving me information if I'm paying attention to it. And then it's done. And then so it ran the analysis, and then it's got another method called the plot results. Now I could jump over this by hitting F8, but I want to jump into it by doing, not step into, but blue, step into my code. And plot results says if the PCA is 9, go backwards. Otherwise, I gave it a directory where it could save these plots. It makes the directory, and it does a few plots, and it's not quite done yet. I guess I should put it down. I'll put it to the end of this. I can jump out of this by hitting this guy right here. Step out. I pop out, and there's my my first two plots. My scree plot. My scree plot is how big are how much variance is explained by each principal component. The purpose of the scree plot, the main purpose is try to decide how many components do I want to keep. And there's no hard and fast rule, but a rule that goes in is look for the elbow in the graph, and in this case the elbow would be like, right around the 4.8. But you can keep more if you think it's more, if it's informative. Keep fewer if you think it's not necessary. And then you get your weights. And we'll talk more about the theory here. And then we have, that's it. And the code's basically run. It's going to do it for every one of the things. I'll hit the red arrow and let it stop. Okay? So go back to the top here. And that's the whole file. All of that work is just really here. You can see here at the top, this. So we have at the beginning of every file, we're going to list the libraries that we need to use. Okay? And the idea is that Python quit unexpectedly. Okay. Not sure. I don't think it really quit. I think it was just me exiting the program. What happens is when you run the python.exe, you get all of the core Python, which is meant to be kept intentionally small. You get things like for loops, you get things like print, you get things like, you get basic mathematics, add, subtract, multiply, divide, and you get some stuff, but not much. But then you import the stuff that you say I need. And you're always going to need NumPy and pandas. Well, it turns out we don't really need NumPy here. We're not using it. And that the IDE is hinting that to me.
Are you saying that because it's grayed out?
It's grayed out. It's telling me you don't need this. And if I'm not using it, I probably should not have it up there, polluting my thought space, right? And we'll see that it gives us an easy way to get rid of that right away. But we'll come back to that in a second. Now, mind you, pandas is probably using NumPy. But pandas controls for itself what it imports when it needs it. My point is, I don't call any, if I put a line right here in my code.
You're not explicitly calling.
I'm not using it, right. But I could put a line here in my code that says, I could say E is equal to npi.exponential of 1, right? So the Euler's constant is the exponential function evaluated at 1. In the NumPy library, and you go back up to the top here, and you see all of a sudden it's like, hey, NumPy, we're using NumPy. So it doesn't complain anymore.
So when you type in NP, it's saying that that's...
Right, so the common abbreviations, again, if you don't use these abbreviations, we will refer you for investigation or evaluation. I don't want to make prison jokes, I don't want to make psychological jokes, but you got to make a joke on occasion. Because everybody's using this. If you come up with your own scheme, I'm going to call it NPy5. All right, go work somewhere else, please. Okay? But again, if I comment this line out, every language has a way for commenting. If I take this line out by putting a hashtag there, again, it's up. Takes a few seconds. And that's what the IDE is giving. It's doing that kind of work behind the scenes. Now I can solve this in the IDE case. I can say, in the case of Windows, it's Alt-Enter. Mac, I got to do Option-Enter. Optimize imports. That tells me it's going to get rid of the ones I'm not really using. So you'll see line 8 will go away, and so will line 2. And then they're gone. Okay, so now I only have the libraries that I need in this file. So I import all the libraries I need. SSL is a library for the secure socket layer. Originally, when I wrote this code, I had it pulling data in for me. So it had to go out of the internet, which meant I need to use internet functions. This .environment, like if you want to go to the Fred website and download data using their API, you create a free account, they give you an API key. You stick that key in your code, and when you call Fred, you say, here's my key, and Fred will give you the data. That way they can keep track of somebody not, doing some kind of thing untoward with their key. Dot environment is just a library that enables me to keep my key from being on the screen when you put it somewhere else, and it goes fine. But then, the all-important function here is from the sklearn library, go to its sub-library called decompositions, and import the PCA function. So the PCA routine in sklearn has been optimized to compute the linear algebra necessary to give you the principal components analysis. And once you have that, the sklearn library has a very simple interface. The way it always works, you can see it down here. So you can see, what did I do here? I said, hey, when I'm running my analysis, I said, hey, I need a PCA model, which I'm going to remember as myself's PCA. And what I say is, call this method PCA, which I've imported up above, usually means call that class and give that class the following information, how many components I want. Every class will have its own set of requirements, what it wants you to tell it, most of which will have defaults, but some won't. All of the logic behind how the class works is available on the internet, of course, at the sklearn website, right? Scikit-learn website. And actually, even all of the code is available. If you dig around enough, you can find out exactly what the code is. That's one of the primary charms or strengths of open source software, is that many millions of people have used the sklearn PCA library, have explored its code, examined it, and we're all pretty comfortable that it does what we expect it to do. And it itself relies on what's known as the, you may have noticed, let me teach you a little bit about our environment. Let's put this thing over here. Actually, I don't need it. I go up to the file menu, which in Windows you don't need to go up. The most important thing you want to be able to access is the so-called, I want it on PyCharm actually. You want the settings function. So the settings function really controls two things. First of all, it just controls how the IDE acts with you, but the really important thing and the thing that makes a very small learning curve, but a learning curve, to be sure, is the part of this that's called build, execution, and deployment. And most importantly, even that, is it's got two parts. Well, no, I want not the build, it's the one above that, the project. It's got an interpreter and an instructor. So let's double click on the interpreter. That's the important one, okay? So when you create a PyCharm project, you have to tell it what interpreter to attach to. And that says, what does interpreter mean? Python is what's known as an interpreted language. What that means is, you don't compile your Python code like you do in C, C++, Java, and then create an executable, and then just run the executable. Instead, you just give Python a text file. You run the Python program, which is a Windows program or a Mac program or system you're on, and it reads every line of that file, and it does things as it runs along. Now, once you run it once, it will remember what it did, so it doesn't have to do that whole process again. But that's what it means to be interpreted. It reads one line at a time in my file, and so you got to tell it where the interpreter is. And what that will mean is, you can see I'm actually I've got a library called QuantCode 26. Our library would be called FNCE. I could probably do that right now. I could probably change it. Let's say add an interpreter, and add a local interpreter, and I want a conduct environment, and I got to tell it, I'm running 3.12, I got to tell it where I want to look. Select existing, and it'll know which ones it knows. It knows about a few of them, and you see there's this 313. Let's see if I can find the one we just created. I don't think I can find it right now. I'm not gonna worry about that right now, but maybe I'll have to help you with this. And over the next several weeks, when you're getting set up, I will be available to set up a phone call with you, let's say, a video where we interact on the screen and I help you get to the point where you can run this file, for example, on your own machine. And part of the task of becoming more sophisticated technologist is do as much of it as you can on your own, obviously. But you get stuck, you need somebody to help you out, right? That's the hard part. When the original C book was written in 1970, the first program traditionally has always been write the words "Hello World" to the screen. And the authors explain in that's the very first program you write in C. It's pretty much the first program you write in any language if you're taking a programming language course. And what the authors point out there is the biggest challenge to getting started in programming is just figuring out how to get the simplest possible program to run on your computer. And that's what Hello World is all about. It's like I have installed Python on my machine, I've created a file, I've written code in that file that says, hey, hello world, and I figured out how to execute that code so that it pops up a message that says hello world. I've now done my first program, okay? I will help you to get that. You can see it has all of the libraries I've installed in here. Now I could go ahead in this same settings place right here, and I could say, you know what? Let's I did systems things. My Mac my PyCharm things. I could go ahead and say create let's add an interpreter and add a local interpreter. It's complaining, I'm going to go select an existing, I'm going to generate a new Honda environment, let's say. Okay, let's put in Python, 312 will be fine. And let's kind of save it here. I'm going to give it a name. Let's call this name, let's call this FNCE 5331. It may complain that it already has one. Okay, let's create an interpreter. Give it a few seconds here. It's more or less doing the same thing we did at the command prompt. Now I've got a new environment, and it gave me a bunch of files, but not that many libraries. It gave me pip. It didn't give me NumPy. It didn't give me pandas. So we'll come back over here, and we'll see. We'll give this a few seconds. You can see down below, right over here, it's saying PyCharm is updating the skeleton, which means PyCharm is figuring out what I've just done and making sense of it so that it can talk to me about what's happening. And we'll soon see that I no longer, if you look up at the screen here, right, I no longer have matplotlib. I no longer have pandas. It's like, you don't have these things. I don't know these things. That's not because they're not on my machine. That's because they're not in the environment that I just created. For PyCharm, there's an easy fix to this. I could just go ahead and say, show context actions, and you know what? Why don't you install all those missing packages? So I'm gonna, if I hit this, it would install all of them, and then this code would run again, and I'd be good. I'm not gonna do that right now, because it'll probably take 2 or 3 minutes. If I try to run this code, by the way, you can see right now I'm in PCA Fred. Fred is the data repository. V2, because I did 2 different versions of this lesson. I get the green arrow and say, hey, run, and it's like, oh, you know what? I can't find that library. PyCharm anticipated this. It says, when you try to run this code, it's not gonna work because you don't have this thing, right? So it's doing the work of reading your code and making sense of it. But I'm gonna go back instead, and I'm gonna do command, comma, with the hotkey. I'm just gonna go back to the environment we already had. And what one was that? That was, I guess it was this one. I don't remember which one I had. I should have noted which one. I guess I was using the 312, right? That's what happened there. Show all. 311. It's kind of weird. It lost track of my 312. All right, well, I'll just go ahead and instead of that, I'm just going to go ahead and tell. Oh, notice now, new feature. It'll actually do the install for you down here. So you can see when you do one install, it'll make a lot of other stuff work, because the other, like Matplotlib probably expects pandas to be there, so it will go ahead and install pandas for me. I'll give it a few seconds. It did, you could do, they all went away. So now I can run the code again, and if I run the code, Matplotlib not found, it's still indexing for a few seconds. Updating skeletons, this is where you have a little patience. The world is fast, but it's not instantaneous. Speed of light, no, yeah. Let's just go ahead and get it installed. Command. Install this account. Let's try again. It fails for some reason. Okay, well, while it's doing its work, let's just take one more look at the document from tonight. Yeah, so we talked about the treasuries a lot, and then we get to see. So we go to the equity sector, and we see that, you know, principal component 1 has 75%, 80%, 74%. That's your beta. That's your first market sector. Principal component number 2 is the sector that you're trading in. Principal component number 3 is value versus growth. That was at least GPT interpretations. You'd have to dig in a little bit to see whether or not you really agree with that. Gemini is smart, you know, but it's not invincible. And then we see the factor loadings. And what this really says is that the first component is made up of materials, energy, financials, industrials, etc., in these weights. So you can see in the 2005 to 2010, I started my data a little bit later, the financial sector is the biggest part of the market. And obviously, up until the global financial crisis, financial sector was, you know, a massive part of the success of the market, right? Banks and other lending entities. Technology is 2 over from that. So actually it says number 2 is value versus growth. Number 3 is cyclical versus defensive. It's kind of funny. I thought it gave me different interpretations last night, which is why I put that caveat in bold red. You know, caveat emptor. We do have nice pictures, which are great to have, but you know, you need to. This is where you still have value to add to the world, from the point of view of making money. You can see by 2010, 2015, the weights are a lot more even. People are spreading out their bets, having been burned by the financial sector. And then let's see, 2015. One would think technology does pick up quite a bit in this one. It's still not quite as, energy and technology are big. Anyway, these are interpretations, right? These weights are definitely associated with these factors. The data for the equity decomposition are 10 different, or 9 different ETFs focusing on those sectors. That's the data. So these interpretations, these labels are what they're representing, and then the sizes tell you what they tell you. So is it true that component 2 is value versus growth? So energy had a lot of value, and technology did not have value. So energy had growth, I guess. Again,
so growth would be the negative side of that.
I think it's, growth is the negative in this case, that's right. And again, they could be flipped if you change
Which would make sense.
the sign of the vector, but it does make sense. Energy sort of depressed in 2020, certainly based on the coronavirus and stuff. And tech is definitely the growth, is going to be the biggest growth. I'm sure we'll see tech as the biggest growth probably in all of these pictures. Tech is the biggest growth. Here, well, actually, utilities are value. Yeah, you can see that, right? That's probably, so you can read through the document and, think, because we have stages of, who we are in the firm, right? How much information can I generate by myself, or with the help of my team, and how good am I at interpreting and understanding what that generation? I mean, I could spin this thing up in an hour. I could probably get through these charts, well, what do they mean? It's great. You know, we all know this issue, right? With an AI, you can write, hundreds of pages of output, much of which is actually very good. Some of it's junk, but a lot of it's just very good. But, somebody's gotta read it, unless
And
it's.
interpret it.
Yeah, unless you're giving it to another AI to do the reading for you, in which case, maybe you should just stay home today and, we'll send your last check where you're living now, It's an interesting time, and it's scary, obviously. It should be a good thing, as the saying goes, the world remains a scary place. The lizard brain is still down there, driving everybody. I gotta get more, winter is coming. All right, so I think that's enough for tonight. Usually I go pretty close to 9:30, always have a break. And I'll have some interesting assignments for you, but let's get the big challenge this week is just get yourself into, you should be able to run this one file, PCA Fred 2, by the time we meet again, whether it's 2 weeks or 3 weeks from now. And if you find yourself stuck, we'll meet and we'll just talk it over.
Do you have office hours, or do you just?
No, we'll just talk. Yeah, you can send me your phone numbers, I'll send you my phone number, always the best. I use Teams, of course, but sometimes I forget, I have a meeting, I'm not as good with the calendar as I could be, you just call me. Okay,
Question.
yes, sir.
With the principal components, like, with this graphs, I see that you have value versus growth.
Yeah.
So, I was thinking maybe, the variables, like we are looking for a variable that contributes to or explains the variation in the, data. But
Well-
if we have two combined, variables like value and growth.
Well, what's really happening, right, is we're telling the algorithm, we're saying, look, I've got these 9 columns of price data for equities, right? And I don't think they are really 9 independent factors. I think that there's a lot of overlap between what drives them. I want you to perform this algorithm so that the first principal component explains as much of the variance in the returns as possible. And then the second principal component explains as much as what's left over. There's actually a good graph, which I meant, I'm glad you asked this question, but I want to pull up this other graph from the slides. Yeah, so this is the first graph, right? This is the second one. So now, what we have here, we've got a different, we've got a 3-dimensional set of points. And now we've fit 2 principal components. And the first principal component is the best explanation in 1 dimension of this. The second principal component of computing is the best plane. So now again, what we've done is we've minimized the distance, not the height, because if it was linear regression again, these lines would be drawn from the existing z coordinate up to the z coordinate on the plane, and we minimize those out. No, in this case, we take the x and the y and we project them onto the plane so as to minimize the distance. And the comment they make is, look, they put colors here. They said, look, you got these green dots, orange dots, green dots, and turquoise dots, right? And it shows you that projected down to 2 dimensions on this plane, it kind of kept the oranges near each other and the greens near each other and the turquoise near each other. So we said, go find these reorganized coordinates, right? We always think of the world, look, here's the x-axis, here's the y-axis, here's the z-axis. My data looks like this. Those are not really the axes that the data is following. This data, it says, there's really only 2 dimensions to this data. It's basically this plane, but this plane is shooting up some 3-dimensional space, so our x, y, z Cartesian thinking doesn't get it. So that's what it gives us, right? But now what we end up with in this picture here, right, is we say, okay, well, what this picture says is, look, This market beta, this value versus growth, this is Gemini's interpretation of what it sees. That's the part where I said in red. Do you agree? Well, let's take a look at value versus growth. Let's see, 1 second here. So, I think probably cyclical versus defensive is probably better. The critical defensive sector is always utilities, right? Because utilities have a fixed, they're very close to being bonds. As long as they run themselves well, they earn their regulated rate of return on their capital. So we probably will see in every one of these graphs that factor is always biggest on utilities, and probably always negative, the opposite way on tech. You're not being defensive when you're gambling on NVIDIA or, dare I say, Tesla or Palantir, right? Or Oracle, right? Oracle had good earnings currently next year. So that seems like at least just quick thinking. But now again, you would not have this. All you would have would be the pictures, and you'd have the labels down here. It'll be up to you to interpret it, right? And it becomes, it's pretty, a little bit of things. So what's the thing that affects all things in a positive manner? That's big. You know that in other parts of the thing. It's not that hard to come up with a second. Value versus growth is a little trickier. You have to really, is that really what's going on here? So this seems, it actually, although it's called value versus growth, it's a little harder to interpret why tech and utilities would be in the same part of that equation. In which case maybe it's wrong, in which case I thought it had a slightly different thing there. I thought it was just a sector thing, but I'd go back and ask, I'd upload the PDF into my AI and say, you labeled PC2 as value versus growth in the equity. Can you explain it to me a little more? And how do you see that, right? And that's the game, right? Because the game is, it tells you something, it's pretty smart, so it's probably right, but I don't get it, so teach me. And then a lot of times, as you know, if you've done it, they'll say, oh my goodness, you're right, that was really stupid of me. It's not like that at all. And that's really where, this is the challenge, right? How do you incorporate, the brilliance of AI, for starters, is it's read everything that's ever been written, right? That's kind of, everything that's true, right? It's, you give it a sentence from the Bhagavad Gita, and it'll give you the next sentence. Here you go. You're probably thinking about when Arjuna was riding the horse, and you're like, yeah, as a matter of fact, I was. And you can throw that in the middle of anywhere. Like you're doing some tech thing, and just throw a little comment about, and then Arjuna climbed down. You see they're making a reference to the Bhagavad Gita. I can see where this fits in with your teaching ML for finance at UConn, and your work as a quantitative analyst. And you are great. It always tells you you're great. I'm very impressed that you came up with that. Oh, thank you. Sort of feel good about myself now too. All right, so we have a break. So let's have a break. Can we get a break? Oh, who has class on Mondays? Anybody? You know what you're here? Monday evening?